Right, so C4 trig, the first thing we'll do is just recap a couple of ideas from C1, C2, and also just look at a couple of definitions. The first thing you need to be aware of is 1 over sine theta is called cosec theta, and obviously sine theta does not equal to 0. Sec theta, rather 1 over cos theta equals sec theta. So you need to be aware of these definitions. And obviously we can't divide by 0, therefore cos theta can't be 0. And 1 over tan theta equals cot theta, where tan theta does not equal to 0. Now in order to memorize these, one of the things you want to be aware of is sine, cos and tan, S, C and T, are essentially the third letter on cosec, sec and cot. So that's what we mean by the third letter. Let's look at the relationship between the graphs of cosec, cot and sec. And let's try and see what's happening here. So once this loads up. And what I'm going to do, you might want to watch this. As I turn this around, guys, as I move this point around, I'll move it first to begin with. And sine of alpha, we know, is essentially a definition from SOHCAHTOA. It's opposite over hypotenuse. And cos is adjacent over hypotenuse, right? So those are essentially definitions. And as I rotate this, it's going to plot on this graph the x and y values. And it'll do the same thing for tan and cot. And it'll do the same thing for sec and cosec. Okay? So the point is not just the graph at the end. The point is look how the graph is actually generated in order to understand the relationship between cos, sine, cot, tan, and cosec and sec. Okay? So I'll do this slowly. So as I turn this around, get to 90, go further down, there's 180, okay, and go down again, and there's a complete circle at 360. Okay, I'll just do that again, go down, just to get all the lines in, and that's what we've got. Okay, I'll suggest drawing a quick sketch of that, but before you do that, what's going on here? What's going on? Let's start with sine and cos. How comes you've got these two shapes? What's the relationship between the two? In terms of their definition. How would you describe the relationship between the red curve here and the blue curve? Is what? The differential? Yeah, okay. Yeah, we can consider that. Yeah.
The red is shifted.
Yeah.
1 unit to the right.
Yeah, so the red is shifted. Okay. And what about the lengths? What's the length? Yes.
They're the same, just one's translated.
Yep, one's translated. And what's the maximum amplitude?
1.
Why is it 1? Go back to the circle. Why is it 1? The radius of this is essentially 1, isn't it? Yeah? Alright, what about cot and tan? What's going on here? Cot and tan. What's the relationship between cot and tan? Inverse. And tan is essentially sine over cos, isn't it? Yeah? Tan is sine over cos. Cot is 1 over tan. And so what is cot in terms of sine and cos? Cos over sine, isn't it? Right? So that means we're plotting cos over sine. If you move this around, how comes it produces this shape? What's the relationship between the shape? It's a, in which axis? In the y-axis, good. Yeah, that's one thing we can see. Yeah, it certainly looks like a reflection of the y-axis. What else? The asymptotes, yeah, there are some asymptotes. But what's the, in terms of the definitions, cot and tan, how do I generate this? So if I just refresh it, let me see if I can refresh it. And if I take a certain point, what's going to happen? So here, look what's happening. Look at, there's two, you might not notice it, probably too small, but there's actually two black dots which are leading the way. And what's the relationship between those two black dots which are creating these curves?
Which two black dots?
They're right at the front, the points leading the front of the curve. So as I move them down, they're actually going forward. How are they related? No. Rabia? Remember the definition? Remember the definition? It's the reciprocal, isn't it? Yeah, so if you define tan as sine over cos, then cot is cos over sine. Yeah, so what we're basically doing is at each point it should give you the reciprocal value at every single point. Yeah?
So what is the black dot denote?
The black, well, that is it. The black dots will get the relationship between them is a is one of it. So at this point, so it's a reciprocal relationship. So as one goes high, the other one goes low, etc. Yeah. So at every single point, your y divided by x, if you want to put it in that way, yeah. If tan is sine over cos, then for cot, your y value is going to be cos over sine. Yeah, so it's going to be a reciprocal relationship. Yeah, so for every x value, whatever y value you've got, for tan, for cot, it will be 1 over that value. 1 over your y value will give you that. Okay, you don't need to worry about it too much, but I guess it's good. And what the sec and cosec obviously just follow the shifted pattern again. Yeah, so if you shift the sine curve it by 90, you get the cosine curve. Right, I'll give you about a couple of minutes. Soon copy that down, and then we'll do a little recap on C2. To do is just very quickly talk about these two triangles. We know that if you've got a triangle, say it's 2, 2, 2, it's going to be equilateral, so the angles between them are 60, 60, and 60. If you were to cut this in half, we'll end up with this sort of scenario. We've got 30, 60, and 90. That's 2 and that's 1. What's this length here then? What's the length of the missing? Yeah.
Square root 2 squared minus 1 squared.
Which is
1.
square root of
1.
nearly.
Oh, sorry. 3.
Square root of 3. Okay. And then that gives us the values 30, 60. Okay. And then we also have a triangle where you have 45 and 45, and that would be 1, 1. If that's 1, 1, what's the hypotenuse? Anyone? Root 2. Okay. And what I'd like you to do is using those values without using a calculator. Obviously C4 is a calculator paper, and yes, you can put these values in, and yes, it will give you the exact value. But at the moment, I just want to make it into an exercise where you don't use your calculator, so you just understand where it's coming from and have a little play around with the algebra. Let's put in a couple of angles. So if I make a little table, 0, 30, 45, 60, and 90, can you tell me what sine theta, cos theta, and tan theta are? I'll give you 2 minutes. Off you go. Alright guys, let's go over this. So, sine of 0, 0, sine of 30, Anyone?
Half.
Half sine of 45? 1 over root 2. Can I just quickly make a point here? 1 over root 2, is this the same as root 2 over 2? In your calculator, I think they give you root 2 over 2, isn't it? When you put in sine of 45. Is it the same? Is 1 over root 2 the same as root 2 over 2?
Yeah.
Yeah.
How is it the same?
Rationally.
You rationalize. So you multiply top and bottom by root 2, and therefore you get root 2 over 2. Okay, so that's something to be aware of, especially when you're looking at answers in a book at the end, once you've done a question, or the final form is given to you and you're wondering how to get it, or you've got a number in your calculator and so has written something else in the book and hang on, how's it the same? So it's the same thing. Okay. And then we've got 45, then we've got 60, sine of 60, root 3 over 2, and sine of 90, 1. Okay. Now, without doing any working out, can somebody tell me the cos values? How are all of these related to the cos values? Sorry? Right. Can everyone see that? It goes the other way round. I can draw an arrow this way, so I'll get 1 on this side, 0 on this side, root 3 over 2 here, and a half here, and root 2 over 2. Okay, so it just becomes inverted, it just flips over. And then by extension, how do you work out tan theta? You can use your values, that's correct. It is a right angle triangle, but there's also a little trick you can do. Because tan theta is the same as what? Sine theta over cos theta. And therefore, if we were to divide, 0 divided by 1 gives us 0. Half divided by root 3 over 2. Anyone?
3 over 4.
Nearly. Half divided by, remember half divided by root 3 over 2 is half times 2 over root 3. The 2's are going to cancel. Root 3 over 3. Square root of 2 over 2 divided by root 2 over 2 gives us 1. And then we've got root 3 over 2 divided by half. Root 3. 1 divided by 0. Can you divide by 0? Undefined. Okay, so the reason why we've done that is just for you to have some understanding, or just revise your understanding on where these values come from, as opposed to just putting them in your calculator and out comes the answer. Okay, so you have some appreciation of these values. Is that right for everyone? Any questions before we move on? Alright. Over here, we know from the sine graph, so we've got sine theta, we've got cos theta, and then we've got tan theta. Okay? Now, the sine of minus theta and the cos of minus theta is what? And let's write this down. The tan of minus theta. How's the sine of minus theta related to sine of theta? Right, so the cos of the sine of minus theta is what? Anyone? What does the sine of minus theta mean? It's a reflection in which axis?
No, y.
Y-axis, right? So if I reflect this in the y-axis, do I end up with the sine of theta? If I reflect it in the y-axis and then reflect in the x-axis, what do you get? Sine of theta. That means the sine of minus theta is minus the sine of theta. Or said another way, minus sine of minus theta equals sine theta. This sort of function is what? Odd. Okay, so let's just be clear about that. Cos of minus theta, when you reflect it in the y-axis, what do you get? Anyone? Reflecting the y-axis. Cos theta. So therefore this is an even function. Tan of minus theta, if we reflect it in the y-axis, reflect in the x-axis, what do we get? Is it odd or even? Everyone's gone quiet now. Come on. Even? So if you reflect in the y-axis, it's odd. Are you sure?
No.
Okay. Hands up. If you reflect tan theta in the y-axis, you get tan theta. Hands up. That means it's even. Hands up. Hands up. If you reflect in the y-axis, then reflect in the x-axis, you get tan theta. Hands up if you're not sure.
The second one.
Second one. Hands up. Second one. Okay, that's better. Okay. So we know this is odd. Okay. So tan of minus theta is minus the tan of theta, or said another way, minus the tan of minus theta is the tan of theta. Now, I won't go into this now, but depending on who you had last year, you have either been taught the cast way or using the graph way. Okay, either way. And either way is fine as long as it works for you. I show students the cast way, but I always encourage them to use the graph way because it reinforces your understanding of how the graphs work, and obviously there's lots of transformation and things like that you need to do. So predominantly, I guess I'll be using the graph way. Right. So let's look at a question, and I'll let you get on some work. The question is, let me put it in here. Okay, let's take this up over here. Alright, write down, Robbie, you might want to look up at this. Right, write down the exact value of cot 120. Now, the moment they've said exact value, that should ring a bell. What are you thinking about? When you say exact value, what are we going to think about? Surds. And when you think surds, which angles are you going to think about?
We said this is the same as this.
Right.
Is that wrong?
Guys, right, so these angles here, 30, 45, 60, 90, and possibly even 0. But certainly 30, what's your name? Certainly 30, 45, 60. Okay? So if you've got something like 150, think about the 30 to give you the 180, for example, right? So you've got the cot of 120. Let's define the cot of 120. So cot of 120 is the same as what? Excellent. Tan 120. Okay. Now tan has a period of, how often does it repeat? Every 180 or every 360? Every 180 or every 360? What's the period for tan? 180. And so therefore the tan of 180, the tan of 120 would be the same as the tan of minus 60. But we know the tan of minus 60 is the same as the tan, so minus x would be minus tan of 60. But we know the tan of 60 is, let's go back, tan of 60, root 3. So therefore we've got minus 1 over root 3. Okay, I'll leave that there. Any questions?